Welcome to today's Partner Customer Academy Live webcast, Easy Onboarding of Mission Critical Java Apps to the Azure Cloud. Presented by Nadi Shalom, Founder and Chief Technology Officer, Gigaspaces, Adi Paz, Executive Vice President, Marketing and Business Development, Gigaspaces. Adi, you now have the floor.
Thank you very much, Angela. We are very excited for this opportunity to share the outcome of the project that was held between Microsoft Azure team and Gigaspaces. Actually, this project had a single goal in mind from day one, to enable Azure users to seamlessly deploy and run mission-critical applications, Java applications on the cloud, or what we call Paint Your Java Azure. Up until now, in a way, I can say that deploying a Java application on Azure was not a simple task. Users had to have deep know-how on Azure configuration, had a bit limited visibility and control for the Java application runtime, and the process was manual, not trivial at all. Today, we will present and demonstrate how you can run your Java application in a native way, as you would run it anywhere else, and not only simple applications, but mainly complex mission-critical apps. So in short, making Java a true first-class citizen in Azure. So I can say that whether you are a Tier 1 enterprise, an ISV, or an MSP, we hope and believe you will find an interest in what we are going to show in the next 45 minutes or so. We try to build the agenda accordingly in a top-down approach. We start with the high-level overview, both functional and technical, and only then going deeper and explain and review the technical elements and the architecture inside. We will start with a short description of the value prop, and then go through the Java application deployment scenario and the high-level product building blocks behind it. This will serve as the baseline for the main part of today's session, which is the live demo of the service. As the live delivery of dynamic screens using webcasts might cause some issues for some of the viewers, experience voice video delays or such, we will use today's screenshots for the session, and a ready-to-download file with a full live recording of the demo is waiting for you at the webcast page on Microsoft side, and a link to be provided at the end of this session, together with a few more information resources that will be available for you to use and download. After the demo part, a more in-depth technical deep dive will follow, in which we will go over the architecture and the main solution building blocks, and then wrap up with the key features you can expect and its availability date. When we started to design the joint Azure Gigaspaces solution and looked for the best way to make our technology as useful as possible for Azure Java users, I can say that 4 key goals were defined. Goal number 1 was to provide the customer with the ability to deploy any Java app onto Azure up to the most complex enterprise Java applications, and doing this with no code change. The second goal was to provide the user with a true enterprise-grade production environment. This includes things like continuous availability and failover, elastic scaling across the entire stack, fine-grained and application-driven monitoring, and fully automating the deployment lifecycle. Well, Azure is a really, really powerful platform. And the third goal we had was to maximize Azure capabilities for the Java enablement projects. And this was achieved through an extremely tight integration between Gigaspaces platform and Azure. And there is one more underlying factor. The solution leverages Gigaspaces' decades of experience in developing application platforms to run large scale, actually in a way we run the world's largest scale mission-critical apps today, which takes me to the next slide. What we have been doing at Gigaspaces for the last 10 years is delivering best-in-class elastic application platform that provides Tier 1 enterprises and ISVs with end-to-end scalability and SaaS enablement designed for mission-critical applications. In a way, I can say that we provided cloud-enabling technology for distributed virtualized environments much before cloud was even termed as cloud. As of today, we are proud to serve hundreds of Tier 1 organizations around the world, running their mission-critical applications on top of Gigaspaces middleware, among which are Dow Jones, Morgan Stanley, Bank of America, Goldman, Sears, Reuters, Bloomberg, Coles, and many others that spread across multiple market verticals such as financial services, e-commerce, telco, healthcare, e-gaming, etc. Our cloud enablement product line, named Cloudify, is now enhanced with a dedicated edition for Azure users, which provides the enterprise-grade application platform to onboard J2E, Spring, and big data apps onto Azure. And with this, I would like to switch to the solution description that will serve as a basis for the demo. Nati, please.
Thank you, Adi. So as Adi mentioned, we'll show a demonstration here. Unfortunately, we're not going to show a live demonstration, but basically a series of screenshots of the actual demo itself. And as Adi mentioned, the demo itself will be available towards the end of the presentation, a recorded version of that. The demonstration itself, to show the value of the integration, what we wanted is to take a classic enterprise stack, which includes the load balancer. In our specific case, that's the Azure load balancer, a very common web container, which is Tomcat, and a database, which could be either SQL Azure and NoSQL database. In our specific case, we've chosen for the sake of interest to pick on Cassandra. Throughout the demo, we'll demonstrate two main things. One is how we can deploy that full stack in one click and make it very simple for Java users to run on Azure. And the second thing is how do we manage and monitor the application after it's been deployed. Now, before we can deploy the application using the Gigaspaces Cloudify environment, we need to go through an initial setup. The initial setup includes several steps that we're not going to go through the details of them. That include the initial setup, creating the user account, downloading Gigaspaces into your own desktop just to be able to run and debug your application, and also using the interactive shell that we'll see later on in the screenshots that will enable you to package the application, deploy, and interact with the actual Cloudify environment on Azure. Obviously, that will also include the management aspect of that that we'll see later on through the slides. Now, once we've gone through that initial step, we're going to end up with something like that. We're going to have the Cloudify controller, which is basically a REST service, which acts as a gateway to the entire Gigaspaces Cloudify environment on Azure. This is how we can monitor the application. This is how we can deploy the application. We'll use that endpoint as the gateway to the Azure environment. The controller itself has an adapter. The adapter itself interact with the underlying Azure environment, and that basically includes the instantiating of new machines and scaling them in or out according to the SLA of our application. This will give us access to also to the rest of the Azure services like the SQL Azure and the load balancer and the blob storage itself. So it will do a lot of those interactions on our behalf behind the scenes. After the deployment, we're going to end up with an environment that you could see on the two instances that are currently presented on the right upper side of the slide. And in that slide, you can see that we have in each machine something that is called in Azure worker role, which is basically the machine. In each machine, we're going to have a Gigaspaces Cloudify agent. The agent itself is responsible for managing the lifecycle of the services within the machine. In our specific case, those services would be the Tomcat for the web container and Cassandra for the database itself. The agent itself is also responsible for reporting back the life of those services and the statistics of those services to the Cloudify management, again, that we'll see later on. So now we're ready to see how the initial setup looks like. So the first thing that we're going to do is basically get the setup and log in into the environment itself. Once you've gone through the login, we'll see the machines, the initial machines, the management machines up and running. Obviously, we haven't deployed the application, so we're only going to see the initial Cloudify environment up and running. And we're going to use the actual URL, the DNS name, as mentioned here, to get access to the Cloudify environment, as we'll see in a second. So here's a view of how the Cloudify management would look like. As you can see here, it includes general statistics on the total CPU utilization, memory utilization of the overall machine that are currently being deployed. It includes also alerts windows that is right now empty because there's nothing running actually. And we can see some general statistics about the amount of services that are currently running on the right-hand side and the ratio on how they're spread over the system itself. We'll soon, once we deploy the application, you'll see more of that. Now that we've got our initial setup, we're ready to deploy our application. So just to be clear, the initial setup is done once for all the applications, so you don't need to repeat that every time that you develop an application. You do that only once. After we've gone through that, we can start and deploy the application, and that includes usually two steps. The first step is the preparation. The preparation itself includes the actual binaries, packaging of the binaries themselves, which is the WAR file, the actual servers that we want to deploy. The binaries itself can be either on our local machines or could be already pre-located on the cloud itself. In our case, for example, the Tomcat and the Cassandra binaries would be pre-located within the Azure environment to save the time of upload. The recipe itself tells the Cloudify environment how to package the application and give it the instruction of the things that we would either do manually, how to deploy them and orchestrate them, both in pre-deployment and post-deployment. So that would include the order of how we want to provision them, and also the thing that we want to tell Cloudify how to manage them in the case of a failure or in the case of a scaling event, and we'll go through that later on. Now that we've gone through that step, we're ready to deploy our application, and that's basically the next steps. So all we need to do is just click on a single command, which is install, and once we've gone through the install steps, the Cloudify will package the application with all the binaries and the recipe included, ship it into the Azure cloud. The Cloudify manager will unzip that file, read the recipe, the instruction from that recipe, and use that instruction to provision the actual services within the Azure environment. In our case, that will be two worker roles, one of them for the web container and the second one for the database itself, as you can see in the diagram here. The end result, if we'll zoom into the web container, would look something like that. So we're going to have a few instances of worker roles up and running. Within each worker role, we're going to have an agent. Within each agent will manage a Tomcat server, and all of them would be connected to a single endpoint, which is the Azure Load Balancer. Now, the instruction that I mentioned earlier, which is called a recipe, is basically the instruction for Cloudify to package, how to package the application and manage that. We'll drill down into what the recipe really means in this slide. So recipe is a DSL. It's a domain-specific language. It is meant for you, the developer of the application, to tell Cloudify how to do a lot of those things through a simple set of instructions. We'll see some of the snippets of how the DSL looks like in a second. But the main things that you need to be aware of is the lifecycle script. The lifecycle script tells how to start and stop a service, how to manage that when something breaks. Usually it would be the same script that you would use if you would run it manually. We just plug them in and call them on your behalf. The other thing that are more advanced are the custom plugin and service binaries. Custom plugins could mean, for example, the management plugins. The management plugin will tell Cloudify how to manage those services. For example, what parameters to monitor, how to display them, and so forth. And obviously the binaries themselves, which could be the service binaries and the application binaries. The application binaries would be our code. The service binaries could be local in our local machine, or could be a URL to a remote reference. In our case, again, the Tomcat and the Cassandra are already pre-located within the Azure environment, because we're not going to change them every time that we deploy a new version of our application. To save you even that step, the Cloudify environment comes with predefined recipes. You could always customize them, but the recipes themselves includes, first of all, the Enterprise Spring application, which is the recipe that we're using in this demonstration. And two other recipes, one of them is for the caching service, the data grid as it is called, and the database itself. So in most cases, the idea is that you'll have pre-canned recipes, and those pre-canned recipes will serve you even from going from that to that. Another thing that is important, even when you do need to make changes to that recipe or create a recipe yourself, that would usually be a single step that you would do for all the applications. Now let's drill down and see a snippet of that recipe. In our specific case, we'll see the Tomcat recipe. As you can see, the recipe itself is called Tomcat service.groovy, and the recipe itself includes the following parts. Just by looking at that, I think that most of you could appreciate the fact that it's pretty self-explanatory. There is a service name and the icon. There is a lifecycle script, and you can see here two versions of the script. One of them is the Tomcat install Groovy, which is written in Groovy, obviously, and also a batch file. So you could mix and match the actual script. You can have any type of script within that initial lifecycle setup. And we can also see the plugin, and this is the management plugin that tells how to monitor the Tomcat service in this specific case, and also the definition of the attribute that we want to monitor and the part of that service. But again, you could appreciate that it's pretty straightforward to look into that, and you don't need to go through a very complex solution. The other thing that is interesting is the scaling rules. The scaling rules tells Cloudify how to manage this service in a post-deployment scenario. Post-deployment, we'll talk more about that. But includes the things that tells Cloudify what happens if in a scaling event, what happens in a failure event. And we can tell Cloudify how to handle those events by telling it what to meter, how to handle a breach in the SLA, and in what specific order, and so forth, and what priority. And we can have multiple of those rules. But you can see that, again, it's pretty straightforward to define those rules, and you could add rules on your own on every metrics that we monitor. Step two of our deployment would be to basically deploy our application after we've defined our recipe, and that basically will look something like that. So the first thing that we're going to do is open the Cloudify interactive shell. The Cloudify interactive shell, the first command that we'll do is a connect command to the same DNS name that we've seen earlier in the previous slide. Once we've connected to that slide, all we need to do is two basic commands. One of them is called use application travel. So that command specifically tells the Cloudify environment to create a context for all the next operation that we're going to do in our system. That basically means that every deployment that we're going to do, everything that we're going to do is going to be displayed within that context, and we'll see how that context is being displayed later on. The second thing that we'll do is basically called the actual install command. The install command gets a simple argument, which is the folder in which our service is allocated. In our specific case, we're deploying Cassandra. Within that folder, there is the recipe itself. And Cloudify knows how to look for that recipe through a name convention. Once we've clicked on that command and the installment has been finished, then we're going to end up with the actual service being provisioned within the Azure Cloudify environment. Now let's see how that looks like by browsing through the Cloudify management. Now what we can see as we log into the Cloudify management is that there is a single box here on the right-hand side showing the progress bar. The progress itself shows that the service itself is being installed, but it's being also in a process of being provisioned. On the bottom, once the service is started to be provisioned, we can see the actual metrics of that service. You should note that the metrics itself would include not just the general metrics, but also the custom metrics of that specific service. And once the provision has been finished, we're going to see that the bar turn into a green V in our specific case to show that the actual service has been provisioned successfully, and we could move on to the next service again, as you can see it here. Now we're ready to deploy the second service in our application, which is the Tomcat service. We use the exact same command that we used to deploy Cassandra, install service, and provide the name of the folder in which the Tomcat recipe that we've seen in previous slides earlier. Once we finish that, note that we've done it again under the same context of the travel context, so we're going to see that added to the Cassandra service. And now we can see that we have two services that are currently running. One of them is the Tomcat service, and the previous one is the actual Cassandra service. The Tomcat service, as you can see here, is in the process of being provisioned, and we'll see later on that it's going to be successfully provisioned, obviously, in a second. And again, like in the case of Cassandra, once it's been successfully provisioned, we can monitor the actual metrics. And the actual metrics will be the things that we define within the recipe itself. And we could visualize them. And another thing that I haven't shown in the recipe is that you could also decide how to visualize those specific metrics. And you could pick and choose which one will be displayed in this specific section. So basically, we got the application up and running. Now we want to see the overall set of applications that are being deployed. In that case, we'll go back to the dashboard that will show us, as you can see here, the services that are deployed and the ratio and how much machines each one of them is consuming out of the total machines in our environment. So what you can see is that obviously the application, the travel application, takes most of the resources. There is the management service that is also taking some part of the resources. We can see the total memory and CPU utilization, but also something interesting that is very useful for troubleshooting is the alert menu that shows us if the system is behaving correctly and if there is any issue, just by looking at the dashboard itself. Now we're ready to log into the application and actually start and use that. This is the application that has been deployed. So again, we've done only a single command. That single command provisioned the database, and then we provisioned the web container. Once we provisioned the web container, the application was automatically being provisioned into that web container and became ready for use using the Cloudify mechanism. Now we can start and browse through the application just to see that it actually works. And once we're going to do that, we're going to see the actual state being pulled out of the service itself as we click on the service searcher. And in our specific case, this is a hotel application, a travel hotel application, and we're going to look for a specific hotel. We'll click on that, and we'll see the results, which basically tells that it's actually interacting with a real database, and it's not just a mock-up. And behind the scenes, it pulled out the right information. Now that the application is being deployed, we need to be worried on post-deployment aspect. What are the post-deployment aspects? The post-deployment aspects are what happens if the application had failed, and also what happens if there is a load. Too many users are accessing the systems and so forth. For that, we have something that is called self-healing. So self-healing is an automation of the process of a failover. If we do that failover ourselves, what we usually do is detect which machine failed, start a new machine, and provision that a new service into that machine that will take over the failed instance. Instead of doing it manually, Cloudify will do that automatically for you, and that's why it's called self-healing. Let's see how that process looks like. So basically, we see here that an instance has failed. Once the instance fails, we get a new instance being provisioned, a worker role instance. Once that instance has been provisioned, Cloudify will provision the service within that specific node. In our case, that's going to be the Tomcat service. It's important to note that the actual failover of the machine within the Azure environment is done by the Azure environment itself. We're not actually replacing that mechanism. We're taking advantage of that. Cloudify basically add to that the fact that the services will be provisioned as well into that machine once it's recovered or once a new instance has been recovered. So there's a nice combo here between the Cloudify provisioning and the Azure platform as a service services that we can leverage within this type of setup. Similar thing will happen in a case of a scale-out event. So scale-out event is actually not that different from a failure event. The reason why it's not that different is that in both cases, we're basically running out of resources either through a failure event or because there are too much load on the system itself, and the current services that are already running can't really keep up with the load. So again, like in the previous case, we have access to the services that are running, and we can monitor them. We can see how they behave, and we can see when they are actually hitting the load through the rules that we define within our recipe. Cloudify will get alert once this event happens, and in that specific case, we'll add another instance, another worker role instance into our environment. That worker instance will automatically join the load in the system itself. In that case, all the load is going to be spread across 4 machines instead of 3 machines, and that's how we get extra capacity into our system. So that's kind of sums up at least the demonstration part of the demo itself, and I think we're ready to wrap up.
So let's try to summarize what we've gone through during the last 30 minutes. Starting with the functional side, the 6 prime features you can expect are as follows. Use your existing application stack, don't change anything. Set the system, keep your application up and running, adjust your application to any cloud, automate the complex lifecycle events such as install, uninstall, deploy, undeploy, start, stop, or any other custom events. Deploy and manage the entire application, not only separate tiers, and get full control and visibility over the constantly changing application in the dynamic cloud environments. These features takes us to the value prop summary that includes 4 main elements. Number 1, which is onboard Spring and Java application to Azure quickly and seamlessly with no code change. Number 2, bring mission-critical and big data applications in the most cost-effective manner. Get full control and visibility by using application and cluster-aware monitoring, and avoid locking by maintaining your existing development practices. The delivery schedule includes 3 milestones. First beta should be available in a couple of weeks. Second beta with features completion should be available for you by end of September, and general availability will follow in Q4. So I would like to thank you all for listening, and we hope you find this information useful. For more details, you can go to videospaces.com/Azure or use the 2 email addresses appear on this slide, one for products and second for support information. As mentioned at the beginning, a complete live demo recording is already waiting at videospaces.com/Azure and also at the webcast offline recording. And with this, we will end this presentation, and I believe we have some time left for Q&As. During this session, we received some interesting questions through the messenger, all of which were answered online by our PM team. Some of which, though, I believe might be relevant for all of us. So I would like to ask Uri Cohen, Videospace's product PM director, to select and read 3 to 4 questions. So Uri, please.
Thanks, Adi. So the first question is, can I use the Azure Management Console to add new instances, or do I have to use the Cloudify tools for that? So the question is, so the answer is you can do both. And basically, generally speaking, when a node crashes within Azure, Azure recovers that automatically. Through the Cloudify integration with Azure, we also make sure that all of the relevant Cloudify components are also started as the node is recovered. and the Azure platform actually reacquires them and makes use of them. The other bit is that failures can occur in kind of higher levels up the stack. So if your service process fails, for example, if the Tomcat instance crashes, or if the Cassandra instance crashes, basically what can be done here is that the Azure agent on each of those instances will take control and will restart those services automatically. In terms of adding or removing new instances, the answer to that is that basically you can do it both ways. When you add a new instance to an existing worker role, for example, the Tomcat worker role, Cloudify will identify that and actually make sure to leverage the new instances. The other bit is that when you actually use the Cloudify shell, you can also type the add instance command, in which case, under the hood, what Cloudify will do is instantiate a new Azure worker role VM and put the application instances on top of that. So that was the first question regarding adding instances and handling failover. Another question is, can I use SQL Azure with Cloudify? The answer is most definitely. So, as we mentioned, Cloudify can handle any stack, any type of application stack that you want to use. In our case, we have demonstrated a recipe that includes Tomcat and Cassandra, but a recipe can also include Tomcat that actually leverages the SQL Azure capability. So instead of writing to the Cassandra instance, it just uses JDBC on top of SQL Azure. So again, it's very, very flexible. You're not bound by any means to the stack that we have shown. If Tomcat is not your application server of choice, you can choose other application servers. In terms of messaging queues, for example, or data stores, this is also possible. So the platform basically enables you to choose any stack that you want. I guess with that, we're kind of wrapping up the questions here. Adi, I'll pass it back to you.
Yes, that's just one more thing to note. Trying it is better is free of charge, so anyone can just start to use it according to the delivery schedule that was presented before. So I'll hand it over to you, Angela, for final words.
Okay, we do have a few questions in the Q&A window. Would you like me to read those for you?
Yes, please. Yes, please.
We do have an attendee who would like to view the release schedule slide again.
Sure.
Okay. And I do have a question. Very good solution. Can you talk about pricing?
Yes, so as I mentioned before, beta is free of charge, and the pricing will be simply based on portion of the standard Azure pricing. So the same model that the customers are used to from Azure will apply here.
Right. And another question: what about data grid spaces and partitioning?
Yes, that's a good question. So that will definitely be supported. Gigaspaces is a well-known player in the data grid arena. So as part of being able to provisioning any kind of stack or any kind of middleware service, this is also including the Gigaspace middleware stack itself, so you can definitely use our own data grid, which actually has built-in data partitioning and content-based routing. This will also be provided as a built-in recipe. So aside from the recipes that we already mentioned, we'll also be providing a built-in recipe to actually provision and use a data grid on the Azure platform.
Great. And another question, what about blob storage, and can I manage tables, blobs, and queues?
Yes, the general answer is yes. Basically, one thing that we haven't mentioned is that the application itself can have full access to any of the stack, any element of the stack of the Azure platform. So we're not blocking it from using any of those services. Azure platform provides a Java API for that, so you could package the Java API and use that directly to the Java API. In addition to that, Gigas Business comes with native .NET integration, so you could also use our native Java to .NET interoperability aspect to interact with any of those services as well. So you can choose the type of interoperability that you want to use to leverage the access to any of the Azure services, the queuing in this case, and the blob store.
And then we have our last question. How do we offer Cloudify to the customers through an EA?
Yes, sure. I guess this question is coming from Microsoft Teams. So all the information, what we have shown on, plus lots of additional supported information is available online at Microsoft microsite. So tons of information is there, or at gigaspaces.com/Azure.
And I just had one more question come in. What is your engagement model in regions where you do not have a presence, for example, India?
I suggest, we can take it offline and speak, with the gentleman specific, just to make the question more clear.
Great. So that is the end of our questions. What you should see now is a web page. Please enter your email address to access the survey questions. We appreciate you taking a moment to fill out the survey prior to logging out. Please be sure to click the Submit button at the bottom of the page to ensure your feedback is received. This concludes today's Academy Live session. All materials from today's presentation will be available at http://academy on this session's webpage. Partners may access the webcast recording through the Partner Learning Center in approximately 48 hours. Customers can access a replay of this webcast and view the live video demo via a link that will be distributed by email post-session. I'd like to extend a big thank you to our presenters, and thank you, audience, for logging in and joining us today.